All right, students, let's get started with our lecture today. All of you can hear me? Please confirm.
Yes,
Yes,
sir.
sir.
Yes, sir, we are able to hear you.
Okay, great. So, guys, I will start with the point where we left in the last lecture. Please confirm. All of you are able to see my screen.
Yes, we are able to see. Yeah.
Yes, sir.
Okay, awesome. So, fine, guys. Let me first tell you what are the various benefits over the Apple Nebula here. And please let me caution you here, guys, that whatever we are going to discuss now in the context of the Open Nebula, you might have seen earlier in the multiple other lectures. So there are again, on the two stakeholders which are present into the picture. The one that we have is infrastructure manager, and another one is the infrastructure user. Another thing that I would like to note over here is that Open Nebula mostly restricts itself to the infrastructure as a service provider. Okay. Proxmox, that also does the same thing. We talked about it in the last lecture. Of course, OpenAvila would also have support for creating the containers, but Proxmox do have the support of creating the containers as well. So that's the reason that we are talking over here about the infrastructure manager and infrastructure user. So clearly indicating here that these are the cloud offerings which satisfy the need for infrastructure as a service. Now, can it be called as a PaaS? Can it be called as a SaaS? Right? There are certain capabilities that we would have to build on these things, but their primary aim is to provide the infrastructure. But if there is a difference in whatever I have stated, and if something else that had may have come up by now, then please bring the same to my knowledge also, because recently I have not checked the same also. Okay. Now let's look into the various benefits which are offered by the infrastructure manager. For infrastructure manager, I'm talking about the infrastructure here, guys. What kind of needs are there? Needs are I need to create the virtual machine. I need to manage the life cycle of the virtual machine. I need to look into the networking piece. I need to look into the image management. I need to look into the scalability of the resources, resizing of my infrastructure depending upon my need, right? How can I isolate the corrupt entities? So these are the various requirements which are there. OpenAbula caters to all of these needs. Okay. Centralized management of the virtual machine, distributed workload, support of the virtual machine placement policies so as to where it needs to be placed, balance of workloads, server consolidation, dynamic resizing of the infrastructure as and when needed, dynamic isolation and partition of the cluster as and when needed, dynamic scaling of the private infrastructure to meet the fluctuating demands, right? Uh, so so that's what like I've been reading basically. So now what are all these of these things? Dynamic scaling of the private infrastructure, then lower infrastructure expenses combining the local and the remote cloud resources. I mean, I'm just reading the from the statements here which are there on your screen. These are the various needs that we usually have, and these are the some of the statements which states that OpenAvila provides all of these things. Now, as a user, I get the full control of the life cycle of the virtualized services management. For the infrastructure user, it also supports for heterogeneous execution environments also. It can host the entities which are running on either Windows or entities which are running on the various flavors of the Linux. And all of these things happens over the web interface, meaning sitting anywhere in the world. I can call out my interface and log in using the credentials and start using the various services which it has to provide. Okay. So guys, these are the main features of the Open Nebula. What function does it do is being stated over here. Now, the first one that I'm going to read through is in the internal interface. This is the GUI. Okay. So this is basically which provides you the command line interface also, using which I can create a VNM, looking into the life cycle of the virtual machine, right? Of course, I can also even specify on which particular host I have to launch my virtual machine. Now, basically, all the external requests which comes in here are being handled by the API calls. These API calls are nothing but the XML RPCs. Okay, basically, They have XML format, and these are remote procedural calls. Okay, so all of this API requests coming from the various, basically coming from the various partners, or you can say from the various users, all are supported in the XML or the RPC format. And it also has an API which provides libvirt virtualization. The libvirt is a library which supports other types of hypervisors, guys. Okay. Then it also has a scheduler feature. This scheduler feature is really very important because it is the one which helps in deciding on which host a virtual machine should be launched, how it has to manage the workload, how it has to manage the resources, how it should be aware of the resources as and when the allocation of the resources happens. All these details are basically the job of scheduler. Then there is another support service called as Hysia, which helps in advanced reservation of capacity. Then we have the virtualization management, managing the virtualization later or hypervisor, what types of hypervisors it can help to manage with. Example, like you have Zen, KVM, or even VMware for that matter. It basically supports three different virtualization layers or virtualization engines. It provides not just one type of hypervisor, but it also provides support to three different types of hypervisors. And along with that, it also has a connector feature for the other type of hypervisor, which is a virtual box. What type of hypervisor is virtual box? What type of hypervisor is KVM? This is a question to all of you. Tell me. Please respond in the chat window. VirtualBox. What kind of hypervisor is it? Type 1, Type 2, Type 3, hosted, bare metal, whatever. What do you know? Tell me. VirtualBox. Quickly. Guys, respond back. Can you hear me well? I want your answers in the chat window. Am I audible? Can you hear me? Okay, Vineet. Yes, very nice. Good. Nikhilesh, you guys know the answer. Yes. VirtualBox is a type 2 hypervisor. Very good. KVM. What about KVM? We talked about it in the earlier lectures, right? What is KVM? Type 1. Very good. So KVM is bare metal hypervisor. Then apart from virtualization management, there are other things as well which needs to be managed here. Okay. Guys, next one is image management. If you recall, we had seen the AMI, that is Amazon Machine Images, that is being managed by the image service. Similarly, here we have got the image management service which helps us to manage the images. Example, like we have transfer of the images, cloning of images, downloading of images, storing, contextualization of these images. All of these things are being taken care by the image management. And obviously, guys, I need to have the network management because I need to have several isolated virtual networks internally because we need to connect the virtual machines internally as well. Okay. And then I have service management and contextualization. When you create a cluster of the virtual machines, how they should talk to each other, be able to support multi-tier services as such. And during the booting of the virtual machines, how do you customize these virtual machines? How to contextualize this virtual machine depending upon your requirement? So all these things are being taken care by the service management and contextualization. Now, guys, next one is security. How do you manage the different type of users, right? And then we have fault tolerance. For you to provide the fault tolerance, you need to first have the state information of your setup. Okay, in order to have the state information of your setup, you need to have some persistent database. Persistent database can actually help to capture each and every small details across and actions inside the cloud. Okay, so using this particular persistent database, what is that we can do? We can get to know what was your last state. How can you restore that state? Okay. And we have the next one as a scalability. It is also tested by launching hundreds of hosts and launching numerous virtual machines, and there are no reports for scalability concerns. Then we have flexibility and extensibility. How can you extend? One of the extensions you saw is that how can you extend the support to other type of hypervisors uh, as such? Okay, it has a features with which it can integrate with other head tools. We would see in the end of these slides how can I have it work with EC2. Now let us look into the some of the internal details about the OpenAbula. Let us deep dive into this. So this is a very high level architecture, guys. Let me be very frank with you people. We do not want to get into too much of the details of the OpenAbula here. The objective of this module is to basically understand from a virtualization infrastructure management viewpoint as to there is a management piece which does so and so job. This is our objective. It consists of three main layers. The core layer, which has a database, it entertains all the requests which are coming in, and it also manages the resources. Then we have drivers, which helps in actual execution of the requests which are coming in. And then you have the tools which consist of scheduler, CLI, and other tools. We will try to now understand each one of it at a high level. So now let's talk about the core part. So if you come to the core part, it is a request manager. It manages all the requests which are coming over in the one format of XML RPCs. These XML RPCs which comes in, they will be about one entity called as OpenAvila entity. It manages and gets the information about one entities over here. Then you have SQL pool. It is the database which holds the state information about one entities. Okay. Then of course we have the virtualization manager, VM manager. As the name itself suggests, guys, it takes care of the life cycle of the machines which are hosted in this environment. Okay. Virtual machines are hosted, but where are they hosted? On the hosts. Okay. So this host manager will interface to the host through the drivers at the below layer, but upper host management is being taken care by the host manager. Then we have the VM manager, which helps in generating the MAC and IP addresses of the virtual machines once they get generated. Moving into the next layer, which is tools. The first one is scheduler. Basically, what does it does is its main job is to run the matchmaking algorithm, which ranks various hosts depending upon the load, depending upon the performance, depending upon the type. Okay, depending upon all of these things, it is going to come up with the ranks of the various hosts, and it helps to create or deploy the new virtual machines. Then you have CLI, which takes input in the form of the commands. These are the commands to manage the Open Nebula, guys. It could be to create a virtual machine, or it could be to create a migrate a virtual machine also. Or it could be to list, delete, and terminate a virtual machine. So change the certain parameter of the virtual machine, something like that. Okay. The way we have one virtual machine, similar way we have one host to deal and manage the underlying host of particular cluster. Now, how to list, how to disable this host for maintenance purpose? Of course, you do have other set of commands which will be for the networks to create subnets, list them, delete them. So these are the basic functionalities of the various components, right? You have support for all of that in the CLI. Let's move further. Coming to the bottom layer, you have the drivers. One is the transfer driver, then the virtual machine driver, and then the information driver. Information driver basically helps in collecting all the information from the various hosts. What kind of information, how much CPU is consumed, how much of the free memory is there, how much of the free memory is consumed, how much of the swap space is there. So various details with respect to the physical hardware infrastructure which is there, it is collected. There are various commands which helps us to understand all of these things. So you just put them the commands and script and run them. It is going to gather all of that information for you. Now, can someone tell me that as to which other tools uses this information for their own needs? So you have these information drivers, right, which are collecting all of this information. Which another block is there which uses this particular information? We just talked about it is used by the scheduler. So scheduler is the one which looks into the process of deploying the new virtual machines. In order to deploy the virtual machine, it has to look into the load, performance, etc. of the host. Basically, scheduler takes decision on the basis of the details inputted by the drivers. The information about the host is periodically collected by the information driver. Thus, information driver keeps on collecting the metrics like free memory, total number of CPUs consumed, total amount of swap memory. All that information is being collected periodically from the hosts which are actually running. It's a frequently conducted activity. Then you have the virtual machine driver, which helps us managing the lifecycle of the virtual machine on the host. So it will help in deployment, shutdown, migration of the virtual machine, polling of the virtual machine so as to look for health of the virtual machine. All these details are being taken care by the virtual machine driver. And then you have the transfer driver. This takes care of the images. Okay. How do you clone? How you can basically take a virtual machine and create image out of it. You can basically clone an image from another image for that matter. You can create a swap space image. So all of these aspects are taken care by the transfer driver. Okay. So this slide tries to say that all of these various modules which are there, guys, this is a very modular design. So you have your scheduler, you have your CLI. It's not a monolithic in the nature. It interacts with the core using the XML RPC, whereas the core itself interacts with the other drivers which are beneath it using the Unix pipes. Unix pipes are the IPC pipes which are deployed in the Unix environment. So how do you construct a private cloud? First, we need to host the front end. It basically gives me the user interface, which will help me to access all the Open Nebula services. Yeah. So now let's talk about this a little bit in more details. So now we are looking at a very interesting topic, guys. We are constructing the private cloud. Imagine that you are the one architect who has to set up the basics, fundamentals, foundations of something like the AWS. So how would you do that? Okay, we are going to talk about that. So guys, first we need to host the front end. It basically gives me the user interface which will help me to access all the OpenAbula services. Okay, then it has interface to the drivers, it has interface to the images. Okay, if at all we want to create a logical volume, if at all we want to create a storage, or if I want to create a network file storage, then I have the provision for all of this. Then to that, I keep on adding the other cluster nodes. When I say cluster, the cluster is aware of the other cluster nodes. Those are the physical resources which are used to create the virtual machines. So there is a SSH access between the front end node and all of these machines. So front end runs the 1D. 1D is nothing but 1 daemon. Some reference was also there on the slide number 20 back. Drivers are also separated processes, guys, using a single text messaging protocol to communicate with the Open Nebula core daemon, which is also called as 1D. 1D is nothing but Open Nebula core daemon. So you have 1D running in your front end, and in all of your hosts, you have the hypervisor running. It could be KVM, Zen, or it could be ESXi. The drivers helps to create the various partitions with respect to storage, virtualization, networking, so on and so forth. Of course, it is not compulsory that you need to separate your front end with your other cluster nodes, okay? So you can have your front end installed in any of your cluster nodes itself. That's also very much possible. Okay, now coming to the storage part, basically let's move on. So here we are talking about the storage part, guys. So the case of the Open Nebula, it supports multiple ways to connect to your storage. Of course, it helps you to connect to the system storage, which is there as a part of your host, or you can even connect to the network file system storage, which is also possible, or you can even connect to the SAN or the NAS using ISC, or you can even connect to the storage, which is a part of the VMware. Now, what kind of connections are provided is shown over here. ISCSCI provides only block kind of storage, like you have the disk, whereas all others are representing in the form of the files. So you have shared, you have, as I said, you have SCCI, you have QCOW. This is the image format in which images shall be stored. It is used to store the images and generally used by the CAMO. CAMO is yet another emulator, which is again another type of virtual machine monitor. So QCOW is basically used as an image format, which is basically used to store the images in the file systems. Okay. Okay. Coming to the networking part, mostly the interfaces between the various nodes and the virtual machines is through the bridges. So bridge networking is basically being used to facilitate the communication between the virtual machine and the host. Bridge networking is also used to facilitate the communication between the virtual machine and the outside world. So again, it supports migration. Now, when migration happens, you have to transfer the huge virtual machines. When I say images, it means the checkpoints and snapshots which needs to be transferred. So it is better to have a good network bandwidth connections between these devices so that the traffic movement becomes easier. Okay, and that's why in a data center, you would see that they are usually connected by the fiber networks. That's the main reasoning behind that. Okay. This is an example to the network setup in the private cloud. As I said earlier, there's a bridge networking which is being used here. And as you can see here, there are two virtual LANs which is being used. So you can see that there are two virtual LANs being created. This is the physical switch. In this physical switch, two the virtual LANs are created. Now these two virtual LANs scatters to the multiple physical networks. Why these two virtual LANs are created? Because it is required for the two different types of the two different clusters. That is two different tenants for that matter. So you can see that virtual machine is running in the host A and using the virtual LAN red, there's another virtual machine which is running on the host P using the virtual LAN blue. So the conclusion is you create different virtual LANs in order to cater to the different subnets. Okay. Then these virtual machines talk to the outside world to the another interface, which is yet another bridge network. Now this particular bridge network is a public facing network. So far, Whatever the bridge network that we created was for the internal network between the virtual machines, clusters, node as such. But other bridge that we are talking is the external facing bridge through which external users shall be able to connect to the virtual machines. Okay. Now the next very important is guys user management. Okay, of course, when you're launching a private cloud, you would also have a lot of users. So you have something like one admin, which means a privileged account, something like the root access. So then there are provisions for the usage, management, administration rights using the various image templates which are there, virtual machines which are there, images which are there, as so as to who can access which particular image, who can access which particular virtual machine. You can also bring the access control list in order to set up the proper way of providing the access control to the users, clusters, data set, stores, etc. Then you have the support for SHA-1 passwords. Basically, this is a part of the authentication and authorization module. Now, this password should be either stored or the file in the file system, or they could be the part of the network environment variables also. Then there's the configuration which is provided, my dear students. For daemon, one daemon, basically you need to do the configuration which is required. Scheduler requires a configuration, driver requires a configuration, virtual machine monitor drivers require the configuration, transfer manager driver requires a configuration. So these are the various configurations which are required, and mostly these are done in the ETC. Okay. Now, guys, moving on to the next part, which is the virtual machines. That's all that we want to learn about the Open Nebula. If you have any questions, I'm happy to take the questions. Please let me know if there are any questions anyone has. I'm happy to take that. Please raise your hand and speak up.
Sir, I do have one question here. I'm just trying to like think in terms of AWS. Are they using the Open Nebula, or there is some different tool kind of that they're using?
Very good question. So, what is your thought process about it? Let's first talk
Ne,
about what is that
ah,
you have understood. I believe that you must be doing some more background, studies as well. So, what is that you think about it? Let's talk about what you think, and then I will add something over the top of it.
I'm thinking it's not AWS. I don't think they are using the Open Nebula. They have different homegrown softwares for
Mhm.
uh, just just like Open Nebula. They are just it's not open. They are using it for their purpose.
Mm. Okay.
But if we want to set up some cloud service, if we want to set up our own cloud service provider things, we can use this Open Nebula to set up the cloud for our enterprise.
Hmm. So, see, listen, first of all, I would like to tell you that yes, you're right. They're not using the Open Nebula. Okay. What is Open Nebula? Simply said, Open Nebula is a cloud management, open source cloud management platform, which is helps you to build the private clouds or hybrid clouds. Okay. So, for
Okay.
example, Open Nebula, we also studied about OpenStack and VMware. We cloud like we didn't saw that, but that's like the same category. Now, what does Azure or AWS guys uses? They use their own full proprietary and which is very highly optimized internal platforms. So, for example, AWS has their own internal platform where they uses the technologies like Nitro. So, if you have ever heard about, there is a white paper out by the AWS, you can study about that, where they mention about the AWS Nitro systems, which is a custom hardware plus hypervisor. For serverless, they are using the Firecracker micro VMs. Again, I studied that long time back into one of the white papers published by the AWS.
Mhm.
And they have their own orchestration in the control plane. But there is no mention of AWS using the Open Nebula or OpenStack. Let me be very clear. Okay, neither of any documentation I found this. Next, Azure, they have their own control plane. They have their own customized hypervisor, Hyper-V as a hypervisor, right? They have their fabric controller. So that's what like these big cloud service providers uses. Now coming to your question, who uses OpenNebula? OpenNebula is usually you would find as a research projects like, for example, universities, or maybe there is a I'm aware from my previous experiences, there is a some telecommunication companies which creates the 5G clouds, right? So they use the
Mm.
OpenNebula. There are some companies which are replacing the VMware because of the cost concerns. They are also using the OpenNebula. For example, like a long time ago, I studied. There was a company called as Akamai. Even today, also Akamai is there. So Akamai uses OpenNebula. That is from their research papers. You can study about that, right? So that
Okay.
is a. Does that answer your question?
Yes, sir. Thank you.
All right. Great. So let's proceed further. So now, guys, we are going to look about the virtual machine. Hmm. So if you want to create any virtual machine for any specific target hypervisor, for example, it could be either Xen or it could be ESXi from VMware or it could be KVM. In that case, there are certain things that needs to be kept in the mind. First one, you have to place the VM context.sh script in the boot process to make the better use of VLANs. The details present in the VM context.sh would help in contextualization of the virtual machine during the boot. That is, it is a process where the virtual machine instance gets configured based upon the virtual machine master script, which provides all the configuration details. What happens in this particular case is that it passes on the arbitrary data when the virtual machine is booting. If you remember in the case of the AWS virtual machine, it has a field called as user data. This user data can be leveraged in order to specify the various softwares or the tools that we want to install on that virtual machine, or basically to customize that particular virtual machine. During the boot time itself, all of this contextualization happens over there. Okay. The second one, you do not pack the useless information in the virtual machine images because otherwise it will get blotted. Okay, do not include swap because OpenNebula can create the swap partitions on the fly in the target host, right? You do not have to include the swap in the virtual machine image. Also, you do not need to have any scratch, basically, for if your volatile storage in the virtual machine image because on the fly, volatile storage can be created in the virtual machine. Scratch storage is something which is temporarily used, right? Third one, you install once and deploy many. That is prepare the master images. These days, it is also called as the golden images. Okay, in fact, we at the Bits Pilani also went through this process of creating the golden image for your lab some time ago. But of course, now the cloud computing, we did not use any such kind of image. But another thing to note about the golden image is that it was created from the running virtual machine instance. This golden image was used to provision hundreds and thousands of the virtual machines which you people are now using these days, right? Now I'm specifically talking about the labs like the network fundamentals for cloud guys, parallel and distributed programming labs, etc. I'm not talking about the cloud computing lab, which is absolutely in the AWS. Now the next one is about the privacy. Do not put any kind of SSH keys in the master images because the master image can be used by many people. It is not really recommended, but you can always use the context to pass on the details. And if there is any arbitrary data that has to be passed to the master image, that should be done using the context. This is analogous to the user data of the AWS. Okay. Now, how do you describe a virtual machine? Obviously, I have to provide a name to that virtual machine. What percentage of the CPU is required? What is the operating system that needs to be used? When I see the operating system, it basically means that what is the kernel pointing to and what is the init. This init is the process for initial booting. Then it is also requires the disk, that is the storage for it to get attached to the virtual machine. Then it needs to get the virtual NIC to which a virtual MAC is provided as well as virtual IP is provided. Okay, if at all you wanted to create a swap space, you can add it to your command. Example like is equal to type is equal to swap. Along with that, you can also give the other information like whether this particular VM can be cloned or not. That information can also be attached. For example, if clone is equal to no, then virtual machine shall be created, but no clone can be created out of it. Okay. Now, guys, let's go to the various virtual machine states. These states all remain mostly basically same across the different hypervisors. The names could change, but set of steps pretty much remains almost the same. These are the various possible states for a virtual machine. For example, first the machine can be in the pending state. From there it can go into the prologue state. Then it go into the running state. From running it can go to the either suspended or stopped or migrated state. Let us quickly go through each of these states. Now, what is a pending state, guys? Let me little detail you. What is a pending state? Say suppose you have successfully submitted our request for the virtual machine creation. Now, where does it go now? It goes to the 1D. What does 1D do? It adds all the information to the database and it set the state to the pending state. Pending state means the virtual machine is yet to be provisioned. In this particular set state, the MAC address and the IP address are also chosen, and at the same time, the informations are also kept into the database. This is a good chance that we would explicitly mention, but there would also be a good chance that we may not mention that. But how do I do provide the option of selecting the subnet and all. I do provide certain details so that the information is stored. The scheduler it awakens every 30 seconds. Look for the virtual machine description where the state information is pending. So the scheduler identifies all the requests in the pending state. Scheduler then identifies the appropriate host depending upon the requirements, right? The host information is being provided by the information driver. Scheduler will make use of that particular information being communicated by the information driver. Using this information scheduled, uh, it will come to know about the load on which the particular host in the same data center. Depending upon the load of each of this particular host and the available space or the resources on that particular host, the scheduler would assign the host to that particular virtual machine. Then scheduler sends the XML RPC message to the 1D, that is to make it run into the selected node. The same can happen in the command VM ID or maybe the host ID also, right? Let's now see the prologue state. In the prologue state, what happens is that the transfer driver prepares the images that has to be used on the virtual machine. It has to take the master image. From that master image, it creates the copy of that master image, which shall be further used to create the virtual machine. If the clone option of that particular file is set to false, what it does? Transfer driver is configured for the NFS. So if I'm not able to clone from that particular image, that is clone image is set to false, here what will happen is it will create a symbolic link to this particular image itself. Okay. And it will be configured for one file system for which it would be making use of image itself. And it also creates a swap disk on the fly. Boot is when the virtual machine is getting to start. Okay. So you specify which particular hypervisor or high virtualization technology basically needs to be basically done. That is about the boot state. Now, which host has to be chosen? All these details are something which are already done. Now, it has to use all of this information and it needs to get started basically to launch the virtual machine. So we can also provide the contextualization information as I mentioned. So you have your ISO image that is wet, which is generally provided as a master image for setting up the virtual machine. So if it has multiple files, for example, like context.sh, which contains the information about the configuration variables. Then we have init.sh, which is a script which is called by the virtual machine to start to configure the specific services. Then it has certificates, which is a directory that contains the certificate basically to validate them. Then we have service.conf, which helps in various service configuration like networking as such. Then you have moving on, basically you have the running and the shutdown states. Running is basically when your virtual machine is actually running and it is particularly polling to see as to how much of the consumption is done with respect to the host, because we need to maintain the certain restrictions with respect to the CPU usage or hard disk usage or RAM usage for that matter. It periodically pulls the information and makes sure that it is well within that particular restricted range which is provided to it. And then coming to the shutdown, the virtual machine driver will send the command to the virtual infrastructure to shut down the virtual machine. Then we have the epilogue state, guys, where here again the transfer manager would come into the picture. It copies back the images for all the images for which save is equal to yes option has been enabled. And whatever the swap space which was created, that shall also be deleted. Any doubts the various states, guys? So this is what about the states overview. Let me know if you have any question, any doubts into that matter. All right. So if there are no doubts, let's move on to understand about the hybrid cloud. We have already discussed about the purpose of the hybrid cloud earlier, guys. Now here we are going to talk about an example of having a hybrid cloud between the Open Nebula and the EC2. EC2, guys, you know, guys, is a service in the Amazon, right? Whi- Which helps in creating the virtual machines. So the EC2 cloud can be managed by the Open Nebula as any other cluster node. Using Open Nebula, I will be able to manage the EC2. Now you can create your account and then you need to add the drivers, of course, through which you can access your EC2 instance. Now, as it states here, you could have basically have multiple EC2 zones and add drivers to these particular zones. Now, I have not worked personally on this aspect, but you can try this out as one of the POCs for your hands-on purpose. So basically, VMs can be instantiated locally in the Open Nebula or EC2. You have two provisionable places where you can provision the machines. This can basically make use of the VM templates, which has all the details of how it needs to be instantiated. Okay, so what are the use cases of the hybrid cloud? We have discussed already. Let's move on to discuss this very quickly. We have on-demand scaling of the computing users. Now, of course, this slide is no surprise to you. In the diagram, you have the machines over here and you have Open Nebula server over here, which is EC2, which is load balancing, right? All the web clients are talking to this particular load balancer. So these requests are going back and this is deploying as well as monitoring. If it sees that there are more requests and more instances are required, then it sends a request for the new deployment of the EC2 platform for creating the new instance. Okay. So that's about the hybrid cloud use cases, guys. If you have any questions or any doubts, please ask me. So the deck has already been uploaded. Now, if there are no doubts, then I'm moving ahead on the different topic for today, which is about the cloud security. This is a very interesting topic that I'm going to touch base today, and it is a very nice or basically very interesting session. It is basically used across all of your cloud world. So any of you who is working on the cloud, you would basically be using this. Please confirm if you're able to see my screen.
Yes, sir.
So guys, let me admit it. Security itself is a very huge topic which spreads in both length and breadth. You take any platform, it's a huge concern. But we will not get into the lot of details, the security as such, but we will just touch upon it, what kind of threat exists to the cloud as such, and we shall move upon from there. Okay. So guys, first and foremost, let us get started with the high availability. So what is high availability? When we talk about high availability, the expectation from the system is that it should continue to function or continue its computing or continue to serve whatever it is doing, even if some of the components have failed. That's the expectation of the high availability. For example, you have your database and you have a lot of queries keeps coming in because there shall be thousands of users then, and they keep on working, accessing to the applications, and applications keep querying the database for one or another thing. In that uh, in that case, we have to make sure that the database is highly available and available for most of the times, right? So of course there are many ways through which you can bring in the high availability. One of the ways for achieving the same is through redundancy. For example, you have a failover server or uh, mm, you have the backup server, so that just in case one server goes down, then the other backup server can take up its place and start serving the request. So through the failover protection or backup servers, you can achieve the high availability just to make sure that if one server fails, then the other server is readily available to serve the traffic. Okay. So what does all of these things helps us with? All of these things helps us with to eliminate the single point of failure. So if you have a single database instance, then that is a single point of failure. If it fails, the business is off. Now I'm talking about the applications and the instances in which it runs. It could even translate to the infrastructure with which we are working. That is the connectivity with which we are connecting to the database. There are a lot of in-between things which basically participate when it comes to high availability. Fine. Now we need high availability. This is for sure. Okay. But why do we really need to go for high HA? Of course, this is not a question which requires answer, but just want to state here for the clarity of everyone that there are a lot of applications which are mission critical in the nature. There are applications which are real-time bound. There can be several applications which are billing specific, right? Real-time transactional in the nature, called as real-time transaction processing systems. So it could look into the examples of the, you can basically go and take example of the banking systems. Like for example, if we have ICICI Bank, stock market systems, NSE, BSC, all of these are very, very important applications because the transactions which happens over there are critical in the nature. It could also be some e-commerce website like Walmart, Amazon, Flipkart. Even a small disruption in their service can lead to losing thousands of the customers and millions of the rupees or millions of the dollars even for a very short duration of the time. So high availability is a prime requirement for the applications when it comes to the cloud environment as such. How do you ensure the high availability? We talked about the high availability, so you can provide redundancy in the things as such. But the question overall is, how do you really bring in the high availability when it comes to the contracts as such? It is done through the service level agreement, that is SLA. You along with the vendor sit together to form an agreement which would state that for so and so service, this is what it is expected. Okay, so one of the goal of the SLA is high availability being mandated for certain components or services. Okay, now of course you can go for high availability, but it also has a cost for you. Initially, you're talking about only one instance of the server now, but you're suddenly talking about everything too. Two instances of the same server to be available. So just to make sure that your services are highly available, just in case one server goes down, the other server can come up and comes into the rescue, right? So if one server fails, then you don't have want to use your user. You don't want your users to face the server not available kind of response. You bring in one more server and thus forms a cluster of servers. It is not going to come for free or cheap. That is going to cost us. It is going to come up with a cost. So you need to look at the pros and cons of having redundancy as well. You need to take a decision based upon the cost benefit analysis. This cost benefit analysis would give you a clear picture of deciding whether to go for the high availability or no for your specific business unit or service. For example, if SLA states that for 99.95% of the time it is available and annually it can go down for 4 hours, that is 4 hours max can be the downtime in a year. This could even be further spread across the quarter. This could say that in every single quarter the services shall be down for 1 hour max. And that time we are talking about here the planned downtime. This planned downtime could be to say that a maintenance activity or do some version upgrade or to perform some data migration and things like that. Okay, it can go even deeper into the details at what time part of the year of the quarter the downtime is expected to happen and things like that. You can define your downtime window, like for example, in every quarter for every first Saturday or Sunday, depending upon your business needs, there shall be some downtime for so and so time. You all might have noticed, right, that we usually get this kind of message from our banks. Depending upon the nature of the business, between 1 and 4, the bank services shall be down. Whether where certain services would not be available. Okay, you must have got some message like that, right? It may so happen that once you log in, probably the page which returns the transaction details might not be available. But if you go and check for some loans or demit things like that, they shall be pretty much available. So this is a clear case of your modules clearly being segregated. I mean, all of these module services are not being hosted or running in the same instance. These are all running as separate modules, separate services. Basically, it could be in the form of microservices architecture, or it could be monolithic architecture with various different modules in the place. Okay, so this is what it is meant by the high availability as such. Now, guys, there are various cases which impact the system availability. One of it is a service outage. This service outage obviously be of two types, like planned outage and unplanned outage. What is a planned outage? So basically, if you have ever heard about between so and so time, some specific services shall not be available for access. Why? Because there might be some maintenance activity which is going on, which is planned by the company. Unplanned outage, this is something which you have not planned. It could be very critical in the nature. Some of the reasons of this unplanned outage could be some human error, some configuration error, some network configuration error, some system issue, could some software failure. Say suppose you upgraded the operating system at your instance, but it did not go well with the version of the the software that you have installed there. Of course, you might have done a lot of testing beforehand to check the compatibility and things like that, but still there could be some chances of you missing it out. And the worst case could be the hardware failure. Now, the software failure, human failure, configuration error, and the things like that are not something which can be resolved easily. But it will take its own time and effort as such in order to be resolved. But hardware failure is something which you cannot even predict to the finest. Of course, to the various other means, you have got your automation tools which you can get to know whether how your hardware is degraded or not, whether it is serving the traffic up to its fullest potential or not, or whether it is degrading. There are a lot of tools which you can use to measure this. When I say tools, basically it is through a lot of analysis. You look into the response time, you look into the throughout throughput of the devices. You look into the how many bytes per second it is getting returned or read. So there are so many metrics for which you can collect the data and come to some kind of pattern which states that you can expect some kind of failure from this particular device or hardware in so and so time. Basically, this is the prediction that we are doing, but this kind of helps. So service outage could be either planned or unplanned. Now, why do we say it is planned? Planned in the sense that there is some kind of maintenance activity. That is, you want to upgrade your server, or you want to migrate from old system to the new system because its performance was degraded, or it was not performing to the fullest of its capability, or you want to move from hard disk to the SSD for disk. So all these things are all planned activities, and your services are likely to get disrupted because of this particular planned activity. And this is definitely manageable. You can plan and make sure that at least number of customers gets impacted because of these activities. So therefore, one is the outage and another one is the degradation. So far in terms of the degradation, we discussed about the hardware degradation, but here we are discussing about the service degradation. What is the service degradation? Expectation is to have like 99.99% of the transactions to be completed in say like 5 seconds. That's the SLA that we want. But if it does not stick to that or violates that, say you have 99.99% of the transactions being completed in 3 minutes, that's where we see the services degradation is happening. I mean, the requests are getting served, but the responses are coming very late. And there is an additional latency to these requests, which are coming in probably. That is something that you do not want as a customer, or that is something that you're not expecting as a customer. There are application setups where you can go ahead and this kind of degradation, but there are some applications where you cannot go ahead with the degradation, especially the new age applications which are coming up. For example, the gaming application, connected car sort of application. These kind of applications should be running in almost real-time scenario. That's the reason most of the applications tend to say that, hey, cloud is not a good solution. But you have to go for other type of solutions where the computing devices are near to the sources, which are called edge computing. I'm sure some of you might have heard about it. There are some of the cases which impact the system availability as such also. Okay. Guys, there are some snapshots that I have captured here. It is pretty old. There are many outages which keeps on happening every now and then. Here we are talking about the outages. The snapshot is from Amazon, which basically pulls our whole worldwide web. It talks about the two outages, one which disrupted the online services, which affected the sites like Amazon, Prime Video, and along with that, it also affected like IMDb, Netflix, and other sites which relied upon AWS. And another instance where the large connection activity was disrupted and there were sites shut down on always for almost 7 hours. Imagine the kind of the problems which are created in the mind of the customers. From point of view of the buyers, they might have been in different stages of the buying online. If you're at the beginning stage, it doesn't matter, right? If you're just trying to make a payment or you've made a payment, not got the response, I mean, there is a series of things which gets linked in how much disruption does it create? Think about it. Another few set of the things, there was an automatic CAD feature which was affected, right? So the device didn't feed it to the cats on the time. I mean, I obviously cannot laugh at this particular situation. I mean, these are not time critical application, but there's an impact for sure. There's another application which was related to the robotics, and its tasks were disrupted, and even the navigation maps on the various delivery applications were also posed in the sense like they just didn't really work. Say you're just traveling and your Google Maps stops working all of a sudden. Then imagine how crazy the situation would be. You have multiple roads cutting and then you do not know where to go because your maps is paused. Right. There's another, incidents that I have taken from the Meta where WhatsApp users had to stay out for 6 hours because of some mismanagement in the protocols which they had implemented, like the broader gateway protocol called as such. The fault was that there was some wrong configuration for the GOAT gateway, and that took down the whole cloud services down for the Facebook. Of course, it is not a public cloud; it was a private cloud which is used by the Facebook. It brought down the whole cloud service of the Facebook. So when you don't have the backend working or you don't have the core applications working, then where would you get the services? Okay, so Instagram was down, WhatsApp was down, and most of the Facebook logins were not entertained. That is, they were rejected. Even if the users were able to log in, they were not able to see their homepage and things like that. And one last one that I would like to cover is from the Google Cloud Network, which returned a 404 error. I'm sure most of you understand 404, resource not available, isn't it? Okay. We're all down. So Google Cloud, Snapchat, Spotify, Discord, right? They all were down because they were using the service of the Google Cloud in certain network configuration, which caused the whole outage. There's some small examples of 2021, 2022 also. Doesn't mean that this kind of unplanned outages would not be there in the future. But in case, because in many cases where human intervention is still required, of course, most of the stuff might be getting automated, fine. But still, in some of the cases, the humans would have to be involved also. So basically, in a high availability SLA for the cloud environment, what is that I need to look for? One, consolidation of the database and applications in the cloud. Okay, and another fact which we have to understand is that these database instance and the application, they share the same cloud infrastructure. For you as a customer, your data as well as application instances would be in the same cloud. But here we are talking about the other customers being there as well as your other competitors being there. Both of you are the customers of the cloud provider, but both of you can be the competitors for that matter as well also. But whenever there is infrastructure downtime, as we discussed some time back, it could disrupt the whole set of businesses which are hosted on the cloud platform, as well as the primary owners of the platform also. The great businesses do get impacted because of these kind of infrastructure downtimes. Another thing that is expected is one size does not fit fits all. Okay, so you have a private cloud, you have a public cloud, you have a hybrid cloud, you have a mixed cloud. Now you have your applications which are hosted in these different servers. It could be purely private, or it could be purely public, or it could be purely hybrid. It is mix of the public and private servers. Your application just does not serve one particular time zone, right? But whenever it is day in Australia, it might be night in the India. Otherwise, vice versa, right? There are so much of the differentiating factors which exist out there when it comes to the serving the request, and not all of it put down in one particular SLA for different type of businesses. So in order to meet various customer needs or application needs or infra needs, there needs to be different type of SLAs for different type of businesses and for different type of time zones. All these things get addressed in the various SLAs. So you have to bring in the high availability for your application, which helps your application to stay alive all the times. But another major question is, how do you really architect them, right? So let's study about that. Now, when you want to architect your system for the high availability for your infrastructure, then there are multiple things which you need to consider. Number one is from your applications or DB's perspective, you have to think about it. Other one is with respect to the cloud infrastructure where your application is being hosted. How are you going to plan and reduce the unplanned outages? You need to architect hardware infrastructure for that purpose. So I talked about redundancy earlier. Redundancy is not just about bringing the two instances of one database server. You have to even go to the level of providing the redundancy in the connectivity also. So you have your network channel connecting to the database. You need to have one more than one, probably two, depending upon how critical your applications is. That is, you need to plan for these redundancies because you never know what point would be the single point of failure. There's a need for us to design the infrastructure in a manner that the planned or unplanned outage is as low as possible. But you can plan whatever all you need. If something has to go wrong, it will likely go wrong. You all know about the Murphy's law, right? But it doesn't mean that you would not plan for all of these things beforehand. Okay. Third one, you have to make use of the best practices, especially when it comes to the configuration. See, when personals are involved, they gain confidence over their work because configuration don't happen automatically on their own. People have to sit and do certain things. When these people are involved, they gain confidences by doing all of these work tasks all over and again in a repeated manner. And they make sure of themselves that they are right. But there are certain slight chances that even these people can go wrong. So it is always good to double check or triple check on all of these things, and that can happen only when you're confident and you're not overconfident as such. So you need to bring the second eye. That is, you need to bring in your scripts, which will run through the configurations and see whatever things, whether the things fits well into the required system architecture or not. So these are extra measures which you need to employ to make sure that you can reduce the outages or downtime. Right. And the last one, how do you migrate the system? There are various architectures which are coming into place. You have hot and cold server configuration. You have one is to redundant servers in the place. Likewise, there are so many methodologies through which you can make sure that the migration of systems happen smoothly. They also try and make sure that the migration don't happen, but try and provide high redundancy through fault tolerance of the failover, just to make sure that you reduce the migration. But there are certain migrations which are required when you want to move from older infrastructure to the newer infrastructure. Let me take an example. Say suppose you want to move from instances which are hosted on servers which are pretty much old in the nature, like 10-year older CPUs, which are not that efficient as such, and the speeds are also not that great, and optimization is also poor. There's a scope for more over there, right? Because of that, you would like to move to a newer setup of the machines, which are hosted by the new set of processors like connectivity, RAM, capacity, and even the hard disk for that matter, as RPM could improve. For example, you wanted to move away from the RPMs of the magnetic disk and wanted to move to the SSD. In all of these things, we are being forced to think about the migration, and migrations are absolutely required in all of those things. Okay. So now how do you achieve this high availability? That is the main question. One is to build for the server failure. When I say server failure, this is taking care of all of the components. It could be the CPUs, network related or RAM related, all those things combined together is what I'm considering as a server failure. So I have to architect my system in such a manner that I can avoid server failure, isn't it? So I have to architect my system. The first thing that I have to take care is going to the level one above. We are talking about the zone level failure, okay? And we also have to take care about the cloud failure. Now we just saw some examples where most of the services failed. That could be the worldwide failure, or it could be the zone failure and the things like that. So what is the one thing where you can bring the high availability into this set of things? Server is a very local item. Zone is a local in nature. Cloud is the biggest distributed system which are in place, which will get scaled across multiple data centers. Of course, they're spread across multiple data centers. So now question comes, how do you bring in or how do you make sure that you're building your system for these type of failures? What is it you need to do which you can leverage in order to build a system for these kind of failures? This is the question to you people. Fine. So we're talking about building the system for taking care of server failure, zone failure, cloud failure. Fine. All of these things are required. Load balancing is required. Elasticity is required. You need to have multiple AZs in the picture. All those things are required. But do you go about doing all of these things on your own? This is the question which you're asking. There's so many moving components over here. How do you make sure that even if one failure happens, failover are smoother in nature? What is that thing which is definitely required in order to make sure that all of these failures are definitely taken care of? The answer is automation. Even the infrastructure controller would have automation in the place. Okay, so you build automation. This means I'm saying you take help of the automation to the maximum possible extent to build the systems which can take care of these failures. So you would see hundreds of the people who are working in the data centers trying to fix the things, which definitely is not the case as we see. There are a couple of people who sit in one particular place and manage the whole data center, which manages the thousands and thousands of applications which are hosting thousands of servers or even millions of servers. So it is that you try and leverage this automation to the max possible extent to build your system to tackle the failures. The three, especially server to zone to cloud, automations are definitely required in any one manner or another manner. So now we are moving into the various SLAs, guys. Let's move into the SLA, very important topic. Let's go back a little bit, where we are talking about the web application. We are still not talking about the enterprise applications, and we are still talking about early days of the web application deployment. Okay, what is the need of these particular applications? This is about the performance of the applications. I have to make sure that this particular application is available, and it will also make sure that it is not able to respond to all the requests which are coming in. Now, there are also, I can define, say I have 24 hours to duration and my server is running continuously. In that situation, can I expect the same kind of the load to be there in all of these 24 hours of the application servers? Definitely not. It kind of varies in the day, in between the day, in multiple weeks, in months, and especially during holidays or the festivals, there is a huge rush. During Wednesday, there is a very less rush. So this kind of variations are there when it comes to the usage of this particular application. And how do you really plan for the provisioning of the servers which are hosting this application? So you have to plan for the peak load. That is, we have to plan for the worst case scenario. We're talking about the peak load, where we are saying that we are trying to provision the server resources, which will make sure it would be able to manage the peak load. We do not want to lose our customers, and thus we do not want to lose our business. We want to survive all of those things. You plan for the worst, saying that it can expect many of this. It can expect these many number of requests to come. So I need to be prepared for it. I need to provision the servers accordingly. Okay. When I say provisioning, what did that involve? You have to decide your hardware configuration. You have to decide on how many physical machines are required. All of them, you need to acquire them and purchase them. Once all of these things are done, then you provision it. Then what happens? Your applications are hosted on those servers, which are dedicated individual servers. So it is a very small organization. They would have a certain set of servers on which applications could be run. And in case of enterprise applications, they have their own data centers in the place. So these applications, what is the need of them? They provide various kind of e-services to the clients. It could be e-commerce or chat applications or some kind of social media applications. A lot of things. That was the case a lot of years ago. So these are all defined with the help of the SLAs, service level objectives. Service level meaning the main aim was on the service in the sense that the request comes and the server respond to that particular request. The target was service, and we had to define the certain objectives for the services which are offered. These are called as service level objectives. Basically, mainly there are two service level objectives which we can think of. One is the response time, another one is the throughput. Response time defines when a request comes in, then the server has to respond in so and so time. It could be millis, like 5 millis, 10 millis, depending upon the time, depending upon how you want your applications to run. Throughput in a given amount of the time, say it could be like 1 minute or 1 hour or given amount of time, how many number of requests are being served. That defines the throughput. These are the two things which are associated with the SLAs, service level objectives. Now you have to make sure that now you have your proper response time and proper throughput being supported. What is it you have to do? You have to have the capacity build up. What does capacity build up mean? Basically, it means that you have to cater to the estimated peak load which is experienced by the application. So I have some examples. As a customer, I know that hey, on Saturday and Sunday it shall be huge rush. Wednesday would be comparatively very less rush. All of these are some examples for the same. You take all of those things and you have a capacity buildup which should cater to the estimated peak load. This activity continues to further being called as capacity planning, where you determine the number of servers which are required to satisfy the requests which are coming in. Not only the servers, you also need to plan the capacity for the servers which will serve the end user's request during the peak loads, where it is going to serve the end user's request. So this particular activity is termed as capacity planning. Okay, this used to be a huge task, a huge task earlier. Even now, this step is required, but things are not that tricky as it is used to be earlier. Okay, so now you're planning for the peak load, guys. Now, whenever you talk about the peak load, obviously you're talking about the n number of the servers, which are definitely much larger from what we used to have earlier, because you're targeting for the peak load. And when you would have the peak load, probably some 2 or 3 times a month or 10 times a year, so you're obviously your infrastructure is growing, and the infra grows, complexity also grows. What kind of complexity? Obviously, your networking is a lot more now. Storage is a lot more now. Number of servers are far more now, and even other component failure is also multiplied. It is all multiplied with a factor of X. In order to manage these huge data center, things become complex in the nature. So what enterprises do? Enterprises started outsourcing the application hosting to that infra providers, because the enterprises cannot definitely do all the job on their own. And moreover, infra optimization is not the vision for the enterprises as such. So they started outsourcing the infra part to that infra providers. What does the job of the infra provider look like? Their job was to make sure that they procure the hardware, they make the hardware available to host the application from the customer's point of view. So now from one stakeholder, now there are two of them. One who is owning the application, owning the data, and wants to host this application in the infra provider vendor, who will be called as infra service providers. And this is where they come to the terms called as quality of service. They define the quality of the parameters, saying that what shall be the availability of the system CPU, the data storage, how efficiently the network shall be implemented during the week load. Okay, so they come up with a legal agreement between the infra service providers and the application owners. This is where things actually started. Slowly, infra providers also understood the game. They also came into the action. Now your application is running 24/7, and there are various stages where your application is not required to be running as such. But there are over the times when it is required to be running 100%. So they started differentiating between these two times, that is a core time versus the non-core time. If I ask a simple question, that what is the core time in India, the answer shall be maybe 6 a.m. in the morning to the 11 p.m. in the midnight. Beyond that, the activities are pretty less. So they can come up with the SLA that states that application availability would be 99.99999%, 9 decimal after 9 comes for the 11 times after the decimal. As such, during the key business hour, that is during this particular time window from 6 a.m. to 12 in the midnight. With this, we as the customers can customize on our SLA and maximize on the server's optimizations. So you would say that for 99.99 for 11 times, the server shall be available for the key business hours. And during the non-key business hours, it will be available for 90% of the time. or the 85% of the time depending upon your needs, right? That's where the SLA could become between the core time versus the new core time, new known core time. Hmm? Another one could be the response time. Say, for example, you have the application which states that the response time during the key business hours should be 2 millis or 1 millis or 10 millis. During the non-key business hours, it could be little more than that. That doesn't really make sense because the response time should be equal during the different times of the day. It cannot be the case that response time would be slower during the non-core hours. In fact, during the non-core business hours, the response time should be even better. Another way to look into the response time could be how do they respond to the issues which is reported. If it is a key business hour, the response could be less than 5 minutes or 2 minutes. It is a non-key business hour, then the response can come in even 2 hours. Okay, that's that can be very well considered. These were called as the infra SLAs or infra service providers who were hosting the applications on behalf of the customers who owned the applications, as they were called as application service providers, which is called ASPs. Now let's try to understand the problem which is associated with the ASPs, application service providers. So what does ASP do? They bought in lots of servers. They started hosting the applications, and in this process, what did they experience? They experienced massive redundancy because they were hosting a lot of servers. But their main problem was that it is always underutilization of many of the servers. Oh. It's not like that for 24 crores by 7 the business runs at its core capacity, right? Mm. Most of the time it is non-peak time for any of the application as such, or it could be varying from the application to application depending upon the time zone and other factors. Okay, but still there is a massive amount of redundancy which is there, which is not helping because servers are underutilized. So they started thinking the ways to optimize on this front. How do you optimize? How do you increase the server capacity utilization in the data center? How do you reduce the massive redundancy? This leads to the new concept called as co-hosting. It means you would not have the application only from your one customer, but you would also co-host in the sense that I could have my data center in the US, which has the applications. Now, I also know the time zone for the other customer in India and America. There's a huge difference in the time zone for both the countries. In fact, whatever is the core time in America for the application is absolutely known for peak hours for the application running in India and vice versa. If it's a busy time in India, it would be night time for the American user. So depending upon the application, say it is being hosted for both the users, that is for users of American India, the two different applications are being hosted. Why? Because the core and non-core time of the different time zones is different. That is how they started managing the co-hosting of application. Co-hosting in simple terms means you basically deploy the multiple applications on the same server. Obviously, this leads to the cost advantage, right? Servers are being used even through day and night. They were redundant, right, earlier, but still the servers are now getting used very much. Now, but this problem brings few set of problems along with the security guarantees, right? Now, what if these two applications are competing with each other? And at those times, we definitely don't have the isolation between these two applications because the databases would host it on the same machine and the application would also host on the same set of the servers. So the resource would be used by both of the servers. And there were times when the resources are being basically there are you know what would happen? What would happen? The resources being reserved for one application are being stolen or being used by another application. So how do you really provide the performance isolation between these two applications in the different time zones? How do you provide a security isolation between these two applications? This was a major challenge when it comes to the co-hosting of the application. Of course, there were a good amount of benefit from this particular co-hosting, but there were also some real challenges which application service provider faced because of this co-hosting. And which was that particular technology which enabled them? What is the technology that brought in the isolation? Answer is virtualization. Give me one moment, guys. Okay? So answer is virtualization technology. Virtualization technique helped overcome these challenges. So they could go in for the virtual machines, they could go for containerization, because of which you could bring in the proper isolation between these two applications, which will actually use when it comes to hardware resources. Okay. So what were the guarantees which were promised by the application service ASPs, application service provider to their customers? They could be enforced due to the virtualization technologies. So these virtualization technologies help to bring in the isolation between application and make sure that don't lead to competition between the resources between the multiple applications. For this virtualization technology to work properly, to make sure that the runtime works properly, the ASP needs the detailed insights into the application runtime. So there were a lot of characteristics of the runtime. They needed a good amount of information, detailed insight about the application runtime, so as to what was the response time, CPU being used, size of connection pool, resources being used. So there were a lot of details which were required, and these information, whatever were required, these were required in high accuracy, because information being received would have to be highly accurate in to help to take predictions. This set of characteristics definitely help the ASPs to allocate the required amount of system resources very efficiently, that too on the demand. You won't have to provision beforehand, right? On demand, you have to allocate the system resources to the application depending upon what is their need as such. So what did this help with? It helped to meet the request rate as well as the response time requirements. And all these details are monitored and the requirements were met very effectively. So for this, again, there were changes in the SLA. There were different SLAs which were required than the earlier infrastructure SLAs. Earlier, we were just talking about what was the response time, throughput, things like that. But now there are new set of characteristics which will come in. They require the new SLAs, and the new SLAs are called as application SLA. We still had the infrastructure SLA, but now new set of SLA came in, which is called as application SLA. And these service providers, which were earlier the infra service providers, now they are called as managed service providers, because they took the responsibility of managing the application availability as well as by looking or monitoring into the application need and response, and they responded to those needs also. Okay. So MSP, managed service provider, is much more than the infra provider now, because he is now looking into the details of what are the application requirements also. What is the application is using. Based upon that, it can go even up to the nature of like extent of scaling of on demand. Earlier, that was not the case. ASPs were not doing that. Everything was there in the place as such. But here, now it is not provision for that application, but it will get provision depending upon the need for which it has to look into the load on the server, how much RAM is being consumed, for some particular unit of time. All those things are measured on the regular interval of the time, and based upon that, it will do the assessment and then go ahead with the elasticity. Okay. So from infra provider, they move to the next stage, which is called as managed service provider, MSP. We still have the SLO, service level objective, which needs to be met. Now, elasticity was also brought into the infrastructure. There was a requirement of in-depth understanding of the application behavior, which was required. That is also captured by the continuous monitoring now. Elasticity also brought in where depending upon the needs, application would grow as well as shrink depending upon the need as well. They move to the bill, right? Not just because your application is being hosted over here, but they move to the stage where they could bill on the application's usage. So if your application is being used for so and so time, then the billing for would happen only for that amount of time. So they went into the new type of billing model, which is also nowadays called as pay-as-you-go model. So all these things were brought into the data centers, which gave rise to the new hosting infrastructure, which is nowadays called as the cloud platform. Now let's look into the various few set of components of the SLAs. So we have service level parameters, metrics, functions, measurement directives that we studied. Let's now have a look at the service level of parameters. It describes an observable property of a service whose value is measurable. What does it mean? Say, for example, if we consider the uptime as a parameter, expectation is 98% uptime. In order to make sure that this 98% of the uptime is being met, what is that we need to do? We need to take the readings at the regular intervals, try to make sure that whether the 98% criteria is being met or not. If it is not being maintained, then probably vendor could provide a discount on the money, right? Which customer is paying. Of course, if it is maintained, then there is no reason for giving the discounts. In that case, it would be fair if it's a win-win situation, isn't it? But customer expects some discount in case in case the agreed SLS were not being met. Okay. Then coming to the metrics basically are the definition of the values that are certain properties being measured. So we will talk about the metrics in the greater details in the upcoming slides. Don't worry about it. This specifies, now next is a function. This specifies how to compute the matrix value from other metrics or other constants. So if you talked about the uptime, then you would have to look into the CPU uptime. What are the other aspects related to the disk reading throughput? All these things need to be considered, and they would be used by a function to compute the matrix value. So this value could be the simple matrix value or compound metric value. Okay, simple metric value could be collected and combined to form the compound matrix also using a function as such. Then we have the measurement directives. These specifies how to measure these particular values. Now next, guys, we have the SLA metrics as such, which are available. Number one is availability we have. So this talks about a particular cloud resource. What is the length of the time it is working for its clients, whether it is 100% or not. So in this, we can consider two metrics like uptime and service availability. Uptime basically talks about as to how long the specific EC2 instance is running without downtime. It basically means that whether the EC2 instance is running for all 100% of the times, and we can check whether the promised SLA from AWS is being met or not. That's what it is about, the uptime. Service availability is a percentage of the time that the service request returns when there is an expected response. So the request is coming in and there is expected response for every request. So whenever someone is using the Azure's web application service for login purpose, every user is allowed to log in and carry on the activity. This is also called a service availability. For some reason, if we saw outages, the users were not able to log in, that's a service availability. Okay. Guys, then we have the response time. Availability is clear to everyone? Tell me from the chat window. Give me the responses. Yes, no, yes, no. Is everybody following? It's a lot of hearing that you have to do today. Okay, this is very, very important. This is very important things that we are talking about. Give me some more yeses in the chat window. Yes or no?
Sir,
Hmm.
one quick ask regarding this key aspects. The first one is like service level parameter is something like uptime and the availability, right? Then what's the exact difference between this metrics and the parameter?
You're asking about the difference between uptime and service availability?
No, sir. The above slide, 16th slide, you have mentioned the service level parameter as the key aspect.
Hmm.
So in such scenario, you mentioned that the uptime is one of the parameter we are considering. But in the
Yes.
metrics also it is there. So what's the major difference between those two?
Nothing is the difference. And we are just talking from the various angles of particular picture. So here we talked about SL service level aspects of the SLA, service level parameters. So these are the service level parameters only. These are the SLA aspects only. Nothing is different. These are the SLA metrics that we are talking about, right? So we are covering the SLA metrics. These are metrics only.
So metrics are like what I mean availability, response time, all these will be a part of the parameter. Based on that, they are charging for the SLA, right?
Yes.
Okay, thank you.
Yeah. So let's discuss about the response time now, guys. So response time is the time taken by any cloud resource to respond to the requests which are coming in. We can consider the response time in the format of the MTTR, which is also called as a mean time to response. And this means, or mean time to repair, right? So we have TTM, time to mitigate, time to notify in TTN, and time to repair, basically time to resolve, TTR. Okay. So now repair is very important because how quickly are you able to resolve the specific problem? It could be either 1 hour, 10 hours, or some days also. It could be either a repair or it could be resolution as such, depending upon what type of system it is. And we have the transaction response time, which means the length of time under which a particular request would get served. Okay, one example could be specific org is using a SES service, how much time it takes to get the confirmation of the email being sent after you have clicked upon the send button. After you press on the send button, you need to get the confirmation of that email, right? How much time does that take? That shall be the transaction response time. Then we have throughput, guys. How many requests could be served in a specific duration of the time, right? Here it is also related to the request and the response, but it also goes one level below to note on the disk write byte level, as well as disk write bytes is a, in input and output both IO. Disk write byte is the metric which helps the rate at which system write the bytes to the data to the disk. Basically, it is a writing activity. So whenever we are writing anything to S3, it's a writing activity, and there, what is that you have basically see there in the S3, whatever you upload, you should be able to see the uploaded file as soon as you uploaded it into the S3. It should not be a situation that it takes a lot of time before the file is being visible in the S3. Then it could also be also involve the link throughput. This is related to how much data is being transferred in a given network link in a specific period of the time. Say between two different places, if a network connection is being defined for 100 Mbps, then that should be the throughput of the link throughout. If not, that needs to be alerted and that needs to be examined. Next, we have errors, guys. So errors is how many errors are recorded. It could be HTTP errors or it could be disk read errors. HTTP errors are percentage of the errors where user sends a request and he gets a response like 500 status code, which means server unavailable for any kind of request as such. That could be basically because of the network outage or server unavailable. That server might have had a bad patch because the modules are not working, or it could be because of the network outage. So all these things would be basically impact the SLA. Next one is the disk read errors. Again, say for example, say you are pulling in the data from the MySQL DB. Now, because of your magnetic disk, which could go wrong, you might get a response or you might not get the data which is actually returned. That could also impact the SLA, right? Then we have the utilization. So the percentage use of the cloud system resources, disk utilization is one of this, and memory utilization is another one. Disk utilization stands for the amount of the hard disk being used, how quickly it is getting used, how much of more is remaining. So these things needs to be monitored. Memory utilization, here we measure the amount of the memory being used by by this instance, how much RAM memory that each connection is making use of, how much RAM memory is remaining. All these things needs to be monitored actively on your dashboards. So some of the things that we talked about are pretty important, and you should be able to really understand them very well. Now, here are the example KPIs along with their corresponding matrices, which are being shown on your screen currently. If you have metric like availability, it is being measured through the MTTR. If we measure the reliability using MTTF, what will be the that will be the basically the measurement. If you look into the various service level ranking and priority, there are many levels which are being maintained. If it is an outage, the response time should be immediate. In that situation, you cannot say that we would come back in 10 minutes or 1 hour or something like that. If it is critical in nature, then as per the industry standard, the response time should be well within 10 minutes and so on. Likewise, there are various target response times which are agreed upon. Then we have the service responses as well. You have your service A, which is communication service between different departments. The SLA for this service should be 99.99999%. The measurement would be in MTTR and MTTF. For storage service, the SLA requirement is 99.99999%, 4 nines after decimal dot. Performance metrics is availability and response time. Measurement can be done in MTTR, MTTF, mean time to repair, mean time to failure, percentage capacity utilization. Networking, hardware endpoints is something we look for 99.99% of SLA. Target is something agreed upon. Again, here the resources utilization and response time are the metrics that we have to look into. Measurement happens in MTTR, MTTF, and data transmission rates. Some example that we can think of is a website. Response time here in this example is being shown around 3.5 seconds per user per request. I think that is outdated request out data that I can perhaps say. Latency example of the database can be around 500 millis per query. For function, I have to find the average latency of web application. Now I need to consider here the latency of the primary server, that is server 1, plus the latency of the redundant server, that is the server 2 divided by 2. That will give me the average latency of the web server. Okay. Then the website response time will be summation of average latency of the web server and latency of the database server. Basically, a function is going to help me to calculate the various other computations using multiple matrices. Okay. Measurement directives. DB latency is the time for the query to respond with the data which is fetched from the database. Then service level objective is an umbrella term for service assurance and website latency. We can say that in case of concurrent connection, the website latency is 1 second, and even for single connection, the latency is also around 1 second. We have penalty. We have at all there's a breach in SLO, then for every minute vendor has to pay some money like 1,000 US dollar for every minute of the breach. So that could be one example of the penalty which could be thought of. Okay. So now let's guys discuss about some of the contractual elements of the infrastructure SLA. There are some random examples that we're discussing here. Values of thresholds could be little different as well. Hardware availability, 99.99% of the uptime in a calendar month. Power availability, 99.99% uptime in a calendar month. AWS goes to the extent of providing most of them in 99.9999% of the uptime. Similarly, data center network availability also has to be 99.99% of the uptime in a calendar month, in any time of the month or throughout the year. Backbone network availability of 99.99% of the time in a calendar month, or service credit for unavailability. Here they are breaching on the SLOs, and hence they are going to provide us some credits like refund or pro rata basis, etc. Outage notification guarantee. Whenever there is a downtime, it should be notified earlier. Internet latency guarantee. When latency is measured at 5 minutes interval to upstream provider, average should not exceed beyond 60 seconds. Packet loss guarantee shall not exceed 1% in the calendar month. So in a whole calendar month, among all the network traffic, there can only be 1% of the packet loss which can be expected. So this SLA has its own life cycle. Initially, there is a sequence of few steps that needs to be followed. We have to identify the various terms and conditions. Then we have to activate in the sense that we have to put it in the place. Then in order to make sure that whether it is followed or not, we have to monitor the system resources to make sure that we are well within the SLAs or SLOs. Once we want to terminate the contract, that's the last step, and after that there shall be no SLA which shall be in the place. This SLA life cycle goes through 5 phases: contract definition, publishing and discovery, negotiation, operationalization, decommissioning. Some of the other parameters could be you could have different SLA classes. Usually you would, when your product gets mature, there could be the different classes which could be defined like silver, gold, platinum is something that customers will do. Depending upon the class, you can define the time in which response shall be coming. For example, it could be immediate for platinum, or it could be little less speedy response time for silver, and like that. Whenever there is a breach, there could be penalty. That could also be the part of the agreement. Again, here a couple of other things that we need to look for is whether you are reaching the threshold, whether the threshold is already breached. So those are two different consequences altogether. Second one also sounds similar. The number of the applications belonging to the same customer that has breached SLA, the number of applications belonging to the same customer that is about to breach SLA, then the type of action to be performed in order to rectify the situation. These are all the various key aspects of the service level agreement. Now guys, with this we move into the multi-tenancy. So now what is multi-tenancy? It is pretty evident with respect to the name itself. Multi means more and tenancy means tenants. In simpler words, in a given space, if there is a more than one tenant in one given space, then it is called as multi-tenancy. Please note, this is not a single tenancy. Now let's look into the pros and cons of this particular figure that we just talked about. Okay, I have a house, I have an apartment. There would be effective use of the land is not there in the case of the house. And in case of apartment, yes, there would be an effective use of the land because they have multiple apartments being built on the top of that. Privacy, no in the apartment, and yes in the case of the house. Infrastructure sharing, no in the case of the house, but yes in the case of the apartment. Yes, the intra is being shared. Maintenance cost sharing, every house does not have a pool. So you could have a pool which could be shared. Obviously, the cost shall be shared with the multiple tenants in the apartment, but in the case of the house, everything would have to be taken care of your own. Freedom in house, how you would have the freedom as it is not shared one. You can make changes. You have the liberty to introduce any changes if you want, which is definitely not the case with the apartment. There are various pros and cons of being in the house and apartment. Let's try to see how does this correlates with other cloud computing model. So this is a traditional, let's first talk about the traditional deployment model. So you have your product being developed. When the deployment goes on premises on the various hosts. Okay, some application is being deployed in on premises, which is being used by individual customers. Like customer A uses the deployment done for its own premise, same for the customer B, etc. This is mostly the single host kind of thing where you have the separate deployment on different servers, possibly, and thus being used by the different type of the customers all together at one place. Now, moving this same application to the multi-tenancy, which is apartment type, multi-tenancy is an architecture. It says that you would have a single instance of your application type which serves more than one customer. You don't have multiple instances of this application which will serve all those customers. It shall be single instance of an application which is going to serve multiple customers. Each of these customers is called a tenant over here, and given that local flavor to that customer, you can allow certain parts of the application to be customized, meaning certain UI parts can be customized, like you wanted to have a color feature which is embedded for your organization, could be the part of your email, that can be the broad thing, or some particular sort of business rule saying that my org has to have this set of businesses business rules uh, which can be brought in, but they should not dictate the application code change. That customization is not allowed. Wherever is allowed, whatever is allowed is very cosmetic in the nature. Example could be the SaaS provider, like Gmail is a good example of it. Most of the organization uses the Gmail for its services as such. And you see customizations as such. You have interface where I have my own logo and things like that. But most of the background code which is actually running, it is all part of the single instance of the Gmail application which could be running. Okay. So here what we can think of is the data which belongs to the tenant is still located in the nature and not visible to any other type of the customer apart from the owner. So this has to be made sure, because otherwise if it is not there, then there would be privacy concerns. As I was saying, what are the other things? Number one is single instance of the software which runs for multiple customers, meaning what multiple tenants across the same instance. So there is a slight difference between multi-user and multi-tenant. Multi-user requires more than one user who is accessing the same application without any changes. Multi-tenant means certain amount of changes that can certainly be brought in, like the cosmetic changes in the UI, etc., for each tenant level. Multi-tenant. So what do we allow the customers to use? The same hardware resources are being used. Number two, same application instances. The same. Number three, same database instances are being used, but they're all configured to each customer needs in a minimal way. So these three aspects where we need to focus our attention with a multi-tenancy are application sharing the hardware resources, offering then it offers a good amount of capabilities to the software, like you make changes to the UI, etc., and things like that. So guys, these are the various models in which the application server can be deployed. You have fully isolated application server. This is definitely not multi-tenancy. I have a tenant A who is using the application server A, and I have a tenant B who is using the application server B. Virtualized application server, using the virtualization, there are multiple virtual machines in a single host. Okay, I have a tenant A who is using the virtual machine A and have tenant B who is using the VM-B. Shared virtual server. Here I have tenant A and tenant B using the same application server which is running, but in a virtual machine setup. This VM is shared between these two tenants. The last one is shared application server. Application server itself is shared over here by the separate sessions or threads, saying that these many threads are being used by so and so applications. These many threads are being used by another applications or by different sessions for that matter. So this is the shared application server model. So these are the various deployment models in the data center, my dear students. This could be fully isolated data center for the different tenants. So here tenants don't share the data centers at all. Then there could be virtualized servers. Here tenants share the same host, but the databases could be running in the different virtual machines. Then there is a shared server. There is one particular host which has the same IP, but different databases. Shared database is also possible where they have various or different databases schemas, same server, same databases, but different across the schemas. There could also be the case where you have the shared schema as well. That is, a tenant shared the same server, the schema as such. So this was about a multi-tenancy. Now let's look about the security aspects.
of it also. Now, as you proceed to the next semesters, my dear students, there are a good number of subjects being lined up for the security as well. On your screen right now is a conceptual framework for the software as a service. You see security column talks about the identity and federation, authentication and SSO, authorization with role-based access control that are the clients are entitled to. What kind of encryption is there in the place? What kind of regulatory controls are there? All those things are the part of this conceptual framework for security. So now comes one big question to all of you. If the cloud computing is so great, yes, it offers a lot of advantages. Should not everyone would have moved by now to the cloud? Why is that they have not people, so many people have yet still not moved on to the cloud? Of course, there is a good distinction, right? After 2019 and before 2020, which is before the COVID, because of the pandemic, right, it helped increase the cloud adoption. Even pandemic helped us to move the online teaching also. Earlier, there were so many reservations when it come to the classes being conducted online. That said, technical education cannot be given online. It has to be in place as such. But the pandemic, there was no other option than adopting the technology. During this particular phase, there was at least 30% of the institutes which adopted one or another software which was cloud bound. So moving to the cloud was a huge thing when it came to especially 2 3 years back during the pandemic. But there are institutes which are still hesitant to go to the cloud. Main reason is being basically cloud acts as like a black box where I do not know uh, what exactly is happening in under the hoods, right? Yes, I see various services and I manage various things on my own, but how are they getting implemented at the grassroots level is something that I mean the clients does not have any clue about. What happens underneath the cloud is something which clients do not know anything about. I mean, AWS would be very honest on their part as a cloud provider, but can AWS promise me the same thing with all the system and network admins as such? Never know, right? Somebody somewhere could tamper the virtual machine or violate the confidentiality where the things could go wrong. So here the cloud is still subject to the traditional data confidentiality integrity problems, availability problems, as well as the privacy issues as such. Excuse me. So here is what is it talking it about is, guys, this particular slide, what can a company benefit if it is to start moving into the cloud? Faster deployment, outsourcing of the IT operations, on demand capacity. So these numbers basically enforcing that most of the companies are moving on to the cloud. But this is what we are mostly really interested into. Okay. You see, 9 out of the 10 companies, they still have the security concerns apart from others like vendor lock-in, compliances, lack of transparency, lack of reliability. A lot of things are there, even in 2019 as such, but major concern being is the security concern. The next concern comes is the overall cost of the ownership. Now I have also listed here, guys, for you some of the security related problems. One is the loss of control. Yes, we lose control depending upon how the things are being deployed. Is there a way that the controls can be taken back? Yes and no, both. Data and the application still needs to be on the cloud, but can the consumer be given the ways to manage them? Okay, so yes, now they have given certain operations where we can actually manage certain cloud resources. Lack of trust is there, but how do I increase that trust? By bringing the various mechanisms like using technology or bringing in the regulatory policies, contracts like that. Then we have multi-tenancy where more than one tenant is using the same instance of that application. If I do make use of the private cloud, then whatever was the reason for me to go away from the public cloud, then my purpose of sharing is now ruled out. I can make use of the VPCs, but still this gives me the pure segregation which is required, no? Then what is that we need to go for? Probably strong separation, which cloud provider these days have started providing. Self-managed cloud still have the security issues, right? There are some other issues also. Loss of control. Some people say that, hey, our application data and all the resources are all located with the service provider, and the way the data is being stored, what servers are being used, etc. Of course, I can do a good amount of selection as such, but beyond that, I still don't have much control over the application of the data where it is getting hosted as such. This could lead to a good amount of concerns. How is this identity management being handled by the cloud? How are the access control mechanism going to be in the place? What kind of policies would be in the place? So we, as a customer, do have to rely upon the provider to make sure that the security is being provided, privacy is being provided. There's a good amount of availability, monitoring, and all those things that we have to really take care about. Then there are various issues in the cloud as well as related to the multi-tenancy also. What if tenants have opposing goals? Say, for example, the tenant wants a better response time, whereas other tenant wants the better response time, uh, but he's too much bothered in the high throughput for a specific period of the time. This is a conflicting situation. Probably one customer gives more importance to reliability, whereas other customer gives importance to availability. So there is a conflicting situation. How do you make sure that the things can work along? You probably have to work on isolation of the things. How do you perform isolation? In multi-tenancy, we saw there are so many ways that can be adopted. You can provide separate servers, you can provide separate virtual servers, same instance, but provide different session intervals, right? Threads. So all of these things are quite possible in the nature. There are variety of the fears, my dear students. Confidentialities, like fear of the loss of control over the data. That is what has happened. I have my sensitive data. Can it remain confidential in the cloud? Okay. What if it gets leaked? We have heard in the past about the several leaks which has happened from the cloud for that matter. Even in the Apple cloud, pictures of the various celebrities which got leaked out. How do you contain all of these things? Will the cloud provider himself be would be honest, or would Bill be making sure that he would not leak the data? There are some questions where we feel, hey, we do have the answer, but we still might be some part of it maybe yet not answered. Okay, then the next one is integrity. I mean, most of these are the questions for which concrete answers are still unanswered, right? How do I know whether the cloud provider is doing the computation correctly? What if it is not being attacked? How do I ensure that whether my provider is storing the data without tampering it in a non-compromisable manner? Okay. What will critical systems go down at the client if the provider is attacked in a denial of service attack? What happens if a cloud provider goes out of the business? Would cloud scale well enough? There are certain concerns which often gets voiced out. Still, the cloud provider argue about the downtime with the user's own data centers. But still, if it goes down and I have control in my own resources, whereas if it goes down in the cloud, how do I make sure that things come back again in the time? And again, then there are some privacy issues which are raised due to the massive data mining. Since cloud now stores a lot of the data and they run the data mining algorithms to get a lot of information from the clients. What if someone else tries to do that? There could be attackers who could attack. I mean, in one of the workshops, the Dr. Dinkar was mentioning, like, who is author of the book Moving to the Clouds. He was mentioning that the hackers could go to the levels of stealing whatever is present in L1, L2 cache and the registers also, right? Then think about it. They have gone to the extent of seeing what exactly is happening in your cache. What are those records which are repeatedly being read and accessed into, to identify what kind of application is being running. So things have gone to that far, my dear students, right? After all, it is a shared environment, right? It's a shared physical infrastructure. So these two applications which are running the same host or the same virtual machine as such, but when you go to the cache level, you cannot differentiate between these two different virtual machines as such. RAM is something you have divided. How would you divide the cache? So that's where people are now moving these days, right? So there is another set of the things like how can the audits be done, forensics. I mean, I'm not providing the answer to all of this, but majorly these are could be the questions which could require concrete answers if your journey involves moving to the cloud. If there are legal issues that states that, hey, who has to comply? What all regulations have to be complied in? What are those regulations which are there? What are the contracts which are provided by the authorities, which are honored by the cloud service providers? All those things needs to be discussed and upfront as such. Defining a threat model which helps to analyze a security problem and helps with mitigation strategy is very important. They analyze the security problem, design mitigation strategy, also evaluate the solution. First step being identify attackers, assets, threats, and other components. Then second step is to rank the threats. Third step is to choose a mitigation strategy. Fourth step is to build a solution based upon those strategies. So you basically design the different boundaries, and then in the boundaries you define what are the basically responsibility associated to that particular boundary. So basic components which are involved in the threat model are, first one is attacker modeling. You have to identify whether the attacker is an insider or outsider. Is he single or collaborated? What is the motivation is coming with? What are the goals that he is chasing? There's also something that we must look for. What are the threats which are expected? Is he going to bring down the whole application down? What are his capabilities? A lot of things goes into the threat modeling. You try and profile the attacker, most of the answers would help you to come up with a strategy to fix and handle on those attacks. I'm not sure if you guys have ever seen the web series called as Pine Gap. It talks about very secured environment, facility in Australia, and combined personnel from America and Australia, basically, which are looking into the details. And one of the analysts observes that hey, the pantry in the temperature was basically the temperature in the pantry was struck at some specific temperature for 4 hours duration. I mean, this is a very very odd event which nobody would notice, isn't it? But he notices that and he tries to bring in. His supervisor asks, "So what?" That activity for sure would have taken place. That proves that the systems are vulnerable. So if someone can plan something and do a very silly activity like this of maintaining the temperature to some specific number for say like 2 hours or 4 hours, and it does not affect in any way, but it proves the systems are vulnerable, right? Then they try and identify what's that malware. Then they know for a fact that it's a airtight. There is no internet connection and all channels are encrypted, but still somebody has done that. So he can be insider. They try to analyze what are the possible faces who can be the attacker, right? They look for that, they hold the discussions, then they even call for the parties, social party, just to discuss on the drinks so as to identify the possible person associated to the attack. So they try to see what has happened from the time they have joined this facility. So a lot of things go into identify the culprit. Finally they end up identifying the attacker based upon some particular information which he or she has sent as a message to some other user. Okay, so I end the today's class with the Pine Gap series. So whenever you get some time, definitely have a look at it. But that's about, guys, your multi-tenancy security and the various aspects of the high availability and SLEs that I wanted to talk about. I'm happy to take any questions. If you have any, please let me know, and I would be happy to answer them. I have already uploaded the content related to this on the Teams. So there is a consolidated PPT that I have already uploaded for you to have a look at it. Yeah.
So, sir, syllabus for comprehensive is ready today. And
Yeah. Good. Thanks for reminding me. Actually, I was there is one more lecture which is talks about uh, the DevOps and scaling strategies on the cloud and deployment and custom containers, APIs, gateways, etc. So I wanted to ask all of you. So would you guys be available tomorrow for a session, for extra session? Maybe something like same time, 7 p.m. or 6 p.m. in the evening. If you do not do that, then also that's not a big problem because that's not a very complex topic as such. It is less like a conclusion of what we all have discussed. But I would appreciate if maybe if you guys have some time and you can join tomorrow. What do you think about it?
Tomorrow we have BDS class from 2 hours or 2.5 hours.
Any other time that you guys would be available tomorrow that we can do this session?
sir, is it possible in the morning?
Morning, what time?
Our networking class is not there, so we can have from 10:30.
No, Baba. That's why I had did a rescheduling now. In the morning, I have some engagement. We have some
Okay.
engagement there. Who's taking the big data systems lecture?
Lakshmikant sir.
So can we do
Lakshmikant,
it
yeah,
on
Lakshmikant, sir.
Monday? I don't know him. Can we do it on the Monday evening? Is it possible to do on the Monday, guys? Monday evening?
Monday evening will be office for everyone.
Sir, Sunday, 8 o'clock, I think we can have for some small time. I mean, by the time BDS will finish.
8 p.m. in the night?
Evening, 8 p.m.
8 p.m. is night, not evening.
Okay. Okay, yeah.
I can do that, but I don't know. I don't know how to find a time for this.
So do we need 2 hours for the session tomorrow?
Maybe 1.5 hours. I can try to wrap it up.
Okay. So
Uh,
our BDS session will be from 5:50 to 7:50 in the evening.
I see. Do you have the number of the Lakshmikant sir? I think I know him. I did talk to him, but I'm forgetting Lakshmikant. If you have the number, please give me. I'll talk to him and we'll see if we can reschedule that.
Have the number, I think email ID we can check.
Is he not there in your WhatsApp group or something?
No,
How are you communicating then?
only on Teams.
It's very tough. Okay, anyways, let me figure out then. We will see, guys. What can we do on that matter? Or otherwise, in the worst case, then we will do at 8 p.m. If you can get the number of Lakshmikant sir, it would be great. I can speak with him today. If not, then let's see.
He's
Hello.
online. Sir, he's online. You can ping him in Teams.
Okay, let me try. Okay, by the way, I guess I would also be opening the quiz. So please try to attempt it by tomorrow, okay?
So from the examination point of view, any suggestions? So, the percentage, will it be equally distributed or mid-semester? End semester, it will be a little bit higher on the percentage.
Yeah. So, one sec. Okay, I have messaged him on the Teams. Let me see if he responds back to me or not. Yeah, what I was telling is, yeah, you should be really careful about all the topics that we have learned in the post midsem and as well as the entire cloud. It would be mostly practical examination. So whatever we have learned, you would find a lot of practical application kind of questions in the paper. Okay.
Yeah. Okay.
Okay. All right. All the best, guys. It was
So,
wonderful catching up. Yeah. Please go ahead. Sorry.
are you going to post one quiz today, sir?
I'm going to post one quiz.
Okay. And one more thing, I don't know, are they everybody is facing? We are not able to see any grading or numbers for cloud computing till now.
Midsem?
Midsem we got it, but quiz and all the quizzes and assignments, nothing is coming in our. We are getting for all other subjects, but I'm not getting anything for the cloud computing. Is that something you can help, or we need to talk to support team?
No, that is not I can help actually. Quizzes is something uh, auto calculated, but I will check on that behalf. Okay. Maybe I can let you know on that.
So
Okay.
Even it is
regarding
not showing for anything, sir.
I'm sorry.
No, even it is not showing any of the quiz for the CC actually. So only for this subject, we are not able to see anything actually.
Okay, let me
For
figure it.
for
Other
others, we are getting.
Yeah,
But
other
for you,
subjects, yeah, we are able to see that.
quiz marks.
yes,
Yes,
quiz
quiz
marks.
marks as well as the assignment marks, everything. Yeah.
Where are you seeing the assignment marks for the other subjects?
No,
If you
assignment
go,
means the grade. If you go to the grade, there you can see that.
Can you
if
show me
you
this?
go, yeah, I can say.
Go ahead. How do I allow you?
Sir, on the same quiz page, we used to see our marks.
Yeah, please show me. Please share your screen, one of you. So if Lakshmikant sir moves the timing of your BDS subject class to 3 to 5, would it be okay?
That
Yes,
should be fine.
I'm
Yeah.
fine. I'm fine. Yeah.
Okay, I'm talking to him. He's responding. Let me see.
Sir, are you able to see my screen?
I can go ahead.
Yeah, there's if you see here, nothing is coming for cloud computing. If I expand, nothing, no. If I go for other subject, things are coming. If I go for big data and see the grades, this is coming like this.
Hmm. Okay, let me figure out, guys. Let me figure out. Okay, I'll try to see for this. Don't worry
Okay.
about that. Thank you. I'll open the quiz. Please try to attempt, and please also ask your friends to do that. Okay.
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 So, regarding,
Mm-hmm.
sir, one question regarding comprehensive exam, because we are giving comprehensive exam for the first time. This is our semester one. So, just wanted to know how it is. Is it similar to a midterm exam or something different in
Similar,
terms of complexity level? Yeah,
similar to that. Similar to that, guys. Don't worry.
si-
Everything will
similar
be
to that.
similar to what you attempted in the midterm examination. Yeah.
Okay, okay. Thank you.
All right. Thank you, everybody. Wonderful catching up with you.
Hello, sir. Yeah,
Tell
sorry
me.
to interrupt. Yeah, so I have one question. So the for the assignment purpose, we have keep the AWS console and all the services and all the server running up there. But now thing is, it all has exhausted. So now the $5 only amount was remaining there. So did the assessment was complete? So okay, we can shut down the servers.
No, I'm doing that, guys, over the weekend. Actually, I'm planning to complete. So please keep it up for a couple of more days, and I'll let you know. Okay. Those groups which will be done evaluation, I'll mail you.
Okay, but what happened if the all the amount was finish up from the console? So
Don't worry
did we?
about that. We'll manage that. Anyways, that is not being borne by you, right? It
Okay,
has a
so
capacity limit. I'll let you know that. Don't worry.
yeah, because we see on the billing dashboard only $5 was remaining, so that's why the concern is.
Sir,
Thanks. Thank you.
we already uploaded the video. Still, we need to make server up and running.
That's what. If you have the video, then I'll see the video. Maybe at times I might need that, but I'll have a look at it and I'll let you know. Okay.
Yeah, yeah.
Cool. Okay, guys, I'll let you know about the timings. Most probably, I'll have a conversation with the Chandra sir. Sorry, with the Lakshmi sir, and I'll let you know, guys. Thank you very much, and I
Thank
hope
you.
to see you tomorrow. Bye.
Bye. Thank you,
Thank
sir.
you, sir. Good
Thank you, sir.
night. Thank you.
Thanks.
Thank
Thank you, sir.
you. Thank you.